Did you know that some elementary particles behave almost like tiny magnets? In this video, I'll talk about quantum spin. So let's begin with definitions. It is a quantum property that some particles have and can be described as an intrinsic angular momentum. Using just this definition, maybe you didn't understand the meaning of this word. So I will explain it using food. But before, we have to understand two topics, angular momentum and magnetic dipole. Do you remember what momentum is? Momentum is the quantity of motion that an object has. You can think of this egg when it's moving across a straight line. And angular momentum measures how much something is spinning or rotating. Now you can think of a mixture, which is making the food travel in a circular path. So this mix has angular momentum. So let's move on to the next cool thing, magnetic dipole. Magnetic dipole happens when the lines of a magnetic field go from one extremity, north, to another, south, just like in your fridge magnets. So the most important concept here is that when you make a charged particle go on a small loop, it creates a tiny bar magnet, or in technical terms, a magnetic dipole. After knowing these two topics, let's go back to the definition of spin. It is a quantum property that some particles have and can be described as an intrinsic angular momentum. Now the trickiest part comes. Electrons and other subatomic particles have angular momentum, but they don't actually spin. They have a property called spin, but they don't spin. To make things clear, I'll use an analogy to explain. If I want to make sweet food, I have to use refined sugar. So every time I have to make something sugary, I need to put this. But now imagine I have a cup of honey. In this case, I do not need to put refined sugar in it or do anything because it is already sweet. It is an intrinsic property of it. The same thing happens to electrons and other subatomic particles. In our universe, to have angular momentum, it is necessary to have some kind of rotation. Therefore, if an object is spinning, it can be considered as having angular momentum. But if it is moving in a straight line, it can't. But subatomic particles already have angular momentum without spinning or doing anything. In other words, just like honey is sweet without having refined sugar, electrons have angular momentum without spinning. And since all charged particles which have rotational momentum create a magnetic dipole, an electron, for example, has its own magnetic field. When you put in electrons in a big magnetic field, the electron can be either aligned or not with the main magnetic field. We call them spin up and down respectively. But for me, the coolest thing is that if there is an alone electron in an orbit around the atom, it magnetizes the whole atom. So if it wasn't for quantum spin, your fridge magnets would not work.